All right, so we'll go over all right, so we're going to go over the other practice problem that had the Excel associated with it, but I'll also kind of go over some topics that I would make sure I review and know. So we'll start out with that. So after tonight, I'll get those of you who did that fourth Excel, will get it graded as soon as possible, and then kind of drop your lowest, and then kind of replace, the weight of these with kind of just one that represents what your grade was in that Excel category. Similar to what I have down here for your individual assignment, connect, and iClick grades. Okay. Excuse me. Then you can kind of play around with that, figure out your grade tool to figure out what you need on the final to get, certain, A minus, etc. Okay. Yeah.
Is the figure out your grade, is that in percent or is it in points?
I think it's like out of 100, like 100. Yeah, it's in percentages. So like you would put like, if I got a 55% in the final, or if I got a 85 or whatever it is. Yeah. Yep. I think I have it all in integers there. Yep. Any other questions? So it'll be what? Ours is Friday at noon. A lot of you are taking it early. So just remind me, show of hands, how many of you are planning on taking it Wednesday at noon? In my other section, so 1, 2, 3, 4, 5 of you then. Okay, so if you do want to take it early, that Wednesday time slot, I have another section I'm giving exam to, works out. We have quite a few extra seats. If you want to do that, let me know. I'll be around. I actually have a 2:15 exam Friday, so I'm here all week. And if you have any questions over the next few days, feel free to reach out via email. I'm pretty available. Other than that Wednesday noon, and then I think I have a Thursday, 9:45 to 11:45 exam. I'll be kind of around the building most of those days. So if you want to meet, send me an email and we can set something up. Yeah.
What room is that exam?
Oh yeah, for the early one. So that's 152. So it'll be that big room by the vending machines.
Oh, thank you.
Yeah.
I'm taking mine tomorrow too.
Yes. So you'll meet me in my office. It's just 119. Yep.
So the Friday exam is in one.
Nope, the Friday exam we meet here. So those people taking it early, you probably didn't see her raise her hand, so you wouldn't know.
Oh, no.
Yeah. So the early exam location was over in 152. If you're taking it Friday, we'll just meet here in our usual classroom. Yep. Okay. I didn't confuse anybody else tonight. I probably should have made sure I specified why I was saying that right. Okay, so this kind of was really not going to look like your exam in the sense of your exam will be short answers and kind of multiple choice questions. I think I mentioned last Friday, I don't remember, so what, 17 multiple choice questions and 3 short answers that have different parts. So although it doesn't look exactly like the format, these are all going to be like questions you could be asked, okay? So let's say I've got this total credit hours and total credit hours squared, and I'm thinking about how can I predict GPA here? So I might do something a little bit different on the exam, which is instead of just say, okay, what would the coefficients be if you ran this regression? I might tell you what they are, and then I want you to kind of draw out maybe what that relationship looks like. Okay, so for here, I told you to run the regression on the exam. I give you what those coefficients end up being. So if I look here, I had total credit hour and total credit hours squared. So just to kind of give us some, I think here's the output for question 1. If I ran that regression, so I get a positive coefficient on the kind of unsquared term and a negative coefficient on the squared term. So what that's telling me is that, right? So that I think about it's predicting GPA. So we'll call this total credit hours and then total credit hours squared. Okay. So this was positive and this was a negative value. So that tells me I have kind of this increasing relationship, but it's doing so at a decreasing rate, right? So the relationship between total credit hours and GPA is going to be increasing, right? But at a decreasing rate. Whereas actually, if we got high enough, right, eventually it's going to kind of start declining, right? But kind of a positive sign, increasing, but at a decreasing rate. Now, if I had the reverse, right, where I had negative and a positive, well, that's telling me that it's going to be decreasing at an increasing rate. So decreasing at an increasing rate there. So, and actually I shouldn't have drawn this on. We can leave this off. Kind of think about what I would expect you to draw is just kind of up to this point or then up to that point. Right? So thinking about kind of the sign of those coefficients and kind of what it's telling us about this nonlinear relationship that exists between my X and my Y variable. Okay? Now, probably more so what I would focus on, I don't believe this is a question on the practice exam here, right? Is if I gave you two values for these coefficients, how could I come up with a marginal effect? So let's say, okay, we know how to interpret the coefficient if we just have a linear relationship here, right? It'd be the effect of one additional unit or one, additional credit hour here on that individual's GPA. But once I include that square term, total credit hours going up by 1 unit here, well, it also go up by 1 unit here. Right? But the marginal effect kind of depends on what level I'm starting out at, right? Am I doing a 1 unit increase from here to here, or is it a 1 unit increase from here to here? Right? So the marginal effect we said was, and I think this is in that formula sheet, right? You'll take that slope coefficient on the unsquared term and add to it 2 times the coefficient on your square term, and then multiply by wherever your kind of starting value for your X variable is, okay? So here, right, what I would have to do is something like this. If someone is currently taking 50 credit hours, right, what would the marginal effect be from them taking 1 additional credit hour, right? So you know that your kind of X value you're starting on is 50. What's the marginal effect from that point? Well, I'll plug my 50 in there, and then I would go to my output and just plug in my coefficient on the unsquared term for B1 and the squared term for B2. Right? So I'm likely going to give you these coefficients, and then I ask you for a marginal effect from whatever kind of starting X value. Here we used 50 credit hours, but whatever the example is. Okay? Yeah. Yeah, so give me 1 second. So I'll show you where it's at. So, oh, I got the wrong classes formula sheet open. Let me go to ours. So here's that kind of marginal effect equation. The reason why we have a 2 there is because really what we're doing, to think about the effect of a 1 unit change, I would take a derivative of this in respect to whatever that thing is that's changing. So if I take a derivative of this function in respect to total credit hours, I end up with B1 plus 2 times B2, and X is still left there. The X variable is still left. So going back and taking derivatives, probably don't want to have to do that anymore. So, having that a formula on the formula sheet will be kind of nice, but that is where it comes from. Yep. Any other questions on that one? So I would review make sure you could think about how to find these marginal effects. And it really shouldn't be too bad, right? You're just grabbing those coefficients from the output, and then I'd have to give you kind of a starting point for that X value, or that X variable. Okay. Any questions on that one? All right, so suppose that you kind of use dummy variables that identify white male, white female, non-white male, and non-white female. So I didn't break this down into several categories, but I kind of differentiated this based off of gender and race, right? So I've got these 4 different categories that someone could be coded as a 1, and all the other ones, they would then be coded as a 0, right? So whatever category they fit into here. If you want to determine that there's differences across these different combinations, you want to include them in your regression, how would you interpret the coefficient on the variables that you choose to include or chose to include? run the actual regression, and also include the additional control for SAT score, and then interpret the results. So if I'm thinking about doing this, right, I had an example over here, right? Now, I think here I gave you these 4 variables, but when I include these in the regression, what am I going to have to make sure I do? Yeah, so anytime I have a categorical variable where, look, you're one of, I mean, okay, I guess if we want to be more nuanced, maybe you don't fit in one of these categories, but let's, for the sake of argument, assume, maybe I do like female, non-female, or, so that way we know that it's kind of an exhaustive kind of set of indicator variables. It's going to identify where someone's at, right? So I have to make sure that I have a comparison, right? Like relative, because the 1 unit change here is going from the 0 to the 1 group. But the 0 group, if I include all 4 of my variables, well, they're actually not a control group. They're in the regression as well. So I have to make sure I leave one out. So I'm guessing the one I left out here was white male, which sure enough, yeah. So then all these coefficients can be the effect of belonging to whatever this group is relative to the white male group. We would expect that the change in, I already blanked. Are we doing GPAs here? Yeah, okay. So the expected increase or expected predicted GPA for the non-white female group relative to the white male group would be about 0.025 points higher, right? The effective kind of individual in question was a white female relative to white male. We'd expect the GPA to be about 0.25 or 4 higher, and then kind of non-white male about 0.009 lower. Although, for these kind of non-white male, non-white female categories, those p-values are so high that here I would say that they really don't have any relationship, right? I could not reject the null. I would fail to reject the null, which anytime we run a regression, what is our null hypothesis? Yeah. Yeah, right? That these slopes are 0. That there's no relationship between whatever x variable we're looking at and that y variable. Now, if we can find a p-value that is less than a certain alpha, right, whatever significance level we set, we then can reject it and say that there is a significant relationship, right? But I think those p-values were like 0.8 and 0.6, so we can't really say that, what was it, non-white males, non-white females have any kind of difference in their GPA relative to that group we left out, which was white males. However, I think the white female category p-value is basically 0. Right? So there we could say that that does have some kind of predictive power, right, for predicting GPA there. It does have a significant relationship. So kind of the key there is knowing you have to leave one group out, and then the interpretation of your coefficients would be, this is the effect of being in this group relative to whatever group I left out, right? So I could maybe do this with, like degrees, right? I have a high school degree, some college, only a college degree or a graduate degree, and I'd have to leave one of those out, probably leave out less than a high school degree, and then every coefficient would be, this is the expected increase in wage or whatever my y variable is relative to that less than a high school degree, which is the group that I left out of my regression. Okay. And I should also add in there, holding constant the SAT score of the individual here, right? Because I did control for that as well. Okay. Any questions for keep moving here? So knowing how to kind of, what your regression equation would look like if you have this set of indicator variables would be, wink, wink, a good thing to know how to do for the exam. Okay. Let's make sure we didn't leave anything out. Run the actual regression. Oh, okay. So instead, include all of the variables that we have and determine which are significant. So I think that's question 3 here. So I just included every single thing. Now, here I wrote down next to it, I don't know why I even typed these in. I must have actually just copy and pasted and left out the formulas, because really all we're doing there, how do I come up with these significant decisions? We kind of just talked about that. I'm just going to go through And if the p-value is less than some kind of given alpha, I'm going to be able to say they have a significant relation. So here, I'm going to use the most stringent one, which is that alpha of 0.01. Okay. So if alpha is 0.01 with 99% confidence, right? Can I reject that null, which was that there was no relationship, and say that these have a significant relationship? So I start going through these. Now remember, e to the negative means move that decimal point that many places to the left. So those are always going to be basically 0. So for your high school ranking and whether or not you're a student athlete, both of those, I could reject the null or say they have a significant relationship. For the next 3, now total credit hours is just barely above 1, or sorry, above 0.01, above that 1% significance level. So I would fail to reject the null for these 3 variables, right? Or I'm failing to reject that there's no relationship. So I would say they don't have, right? They don't have enough evidence to say that they have a significant relationship, or there's not a significant relationship between these 3 variables and my y variable of GPA. And I just kind of go through the rest of these, right? So, oh, where's my p-value? There we go. So this one's not significant, 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 and then these 2 would not be significant as well. Okay. At least at that highest level, right? Even for this like non-white female variable, once I include all of the other control variables, it's close, right? I could say it's significant at the 95% level, right? But not quite at that 99% confidence level. Any questions on that? Shouldn't be too bad to like determine which variables have a significant relationship. It's really which ones can you reject that null for. Okay. If I'm looking at this model relative to the previous one, how much more variation those additional control variables allow me to explain about GPAs? So kind of comparing this to my earlier regression, the additional variation I can explain with what? High school rank all the way through high school size would be what? Yeah. Yeah, my R squared went to about 29%, or the proportion I could explain of the variation in GPA was 0.29 using all these variables. Whereas when I didn't include those additional control variables, I was only explaining about the proportion of variation I was explaining was 0.2, or about 20%. So yeah, roughly 9% increase in the amount of variation I could explain. Okay. And then what's the last one? Okay, this is a good one to go through. So are any questions there before we keep moving? Got one more thing I want to say here before I do the 4th problem. Let's say that I want to let's say I've got these additional variables included in my regression, right? And let's say I really want to, determine whether or not there's some type of, which one of these want to pick on? Let's do SAT scores. Yeah, I think it's an easy one. So let's think about this SAT score, right? I'm picking up this coefficient, right? So I'm seeing the estimate of that coefficient, but it's going to be picking up the true relationship plus, I'm going to call this some additional bias component from some variable that I'm leaving out that is important at predicting GPA. So I'm thinking about my SAT score. What's something that could be correlated with my SAT score, but also correlated with my GPA that wasn't in that regression? Yeah. So I would agree with you, other than this data set only has high school player individuals that are currently in college, right? So we haven't completed it yet. I want to think of a slightly better one just so we can make sure that we hammer the relationship a little easier. So one I would think of, once again, I wouldn't make you necessarily come up with one in the exam. I would give you maybe a variable that we left out. So let's say, although the education one was probably very similar to the one I'll go through. But let's think about, we left out kind of we could even do parental income here. Makes a little bit more sense, right? Or kind of the socioeconomic class that someone's coming from. Right? So if a college student's parental income or kind of family income, their socioeconomic background is going up, what do you think is probably true about the SAT score of the individual as well? It's going up, right? I can tell you right now, a lot of people that are living in like inner city Chicago are not, don't have as many resources to study for the SAT as the suburbs, right? So, higher amounts of income are kind of probably positively correlated with how well someone does on the SAT. Now, it really doesn't say much about their intellectual ability necessarily, right? But it's like they're going to be more prepared to have more resources that help them do better on the SAT score. Also, with parental income or higher, what do you think is probably true about the relationship between income? And remember, this is the coefficient that would exist if you included income in that regression to predict GPAs. What do you think is probably true about income and GPA there? And you could just state this on the exam, but I would guess that if anything, there's a positive relationship there. So the estimate I'm seeing is going to be what? Too high or too low if I leave out that parental income variable. Positive times a positive divided by variances are always positive. So I'm going to have this additional positive coefficient. So the coefficient I'm seeing is actually going to be greater than the actual effect, right? Because it's going to include the actual effect plus this positive bias amount, right? Or plus, you can even think about some number, right? It's going to have this additional number added in that's going to overinflate it from what the real effect of that SAT score variable would be. If I leave that other omitted variable out that I think matters. Now, you could actually almost make an argument here. If you made a strong argument, right? I don't know. I actually haven't really looked at the data. I don't know if because there's not a lot that exists that's easy to get your hands on. But what could you argue this effect would be of parental income on GPAs? Possibly you could argue this is approximately 0. So if I leave something out of my regression, and even if it's correlated with something I did include, like income is probably correlated with SAT scores. But if once a student's in college, parental income isn't really impacting their GPA once they're there, well, notice then my bias would actually, if this was 0, my bias actually wouldn't exist. So it's okay if you leave out a variable that's correlated with something you included, but not correlated with your Y variable, right? Because then this bias component would just be equal to 0. Right? Now, that's likely not, there's likely going to be some relation. There are things that have no relationship, but more often than not, these omitted variables that we think are important, right? We think they're important because they're correlated with both of these things, okay? So once again, I think we did that on Friday a little bit, but know how to sign your bias, right? And think about this. And that equation, although I think I don't know if I showed this to you. I think I might have just written it down, is right here, okay? So you'll have that on that formula sheet as well. And also, I want to point something out. I think I put this up there. You can ignore this set of questions. I think I showed this stuff to you when we were doing Anova, but I'm not going to actually make you use these. They're just there to have this set of equations we looked at. So this was like Anova stuff. Really, all I expected you to do there, I said on Friday, was use those p-values to determine is there variation across the rows or columns. Okay. So the final question is talking about interaction terms. This is also something that would definitely be a good thing to know going into the exam, okay? So suppose you've got an interaction between an SAT score variable and athlete, right? So if I want to think, I'm still predicting GPAs, but now I've included this interaction term, okay? So how would I interpret that coefficient on the interaction term and maybe think about some other things here? So I just kept this simple, right? Let's say I wanted to determine whether or not the predictive power of the SAT score was different for athletes versus non-athletes. Right? So I included this interaction term of the two. Okay. So here, how would I interpret this SAT score kind of coefficient? It would be a 1 unit increase in the SAT score would predict that the GPA of a non-athlete goes up by 0.0019. So this is where I can actually kind of come up with two interpretations for the different groups. So the effect of the SAT score, or sorry, the correlation of the SAT score with GPAs, right, for non-athletes would just be what, 0.0019. Because for non-athletes, this is going to be a 0. 0 times anything is 0, so that has absolutely no impact. However, the effect of a 1 unit increase in SAT score for athletes, well, if SAT went up by 1 unit, this would get added into my prediction, but also now this is 1, right? If they're a student athlete, that'll be a 1. So 1 times a 1 unit increase, they would also, that prediction would change by whatever this coefficient is as well. So to get the total effect, this is kind of like, right, 1 unit increase in SAT for a non-athlete would increase, predict their GPA would increase by 0.0019. But for an athlete, what? The kind of total effect of a 1 unit increase in SAT would I would have to add that coefficient on SAT to that coefficient on my interaction term as well. Okay. So I could kind of break this down for the two groups, or I could interpret that coefficient on the interaction term as what? So it's going to be the additional correlation or the additional change in the predicted Y variable for whatever group is coded as the 1. So the additional kind of change in the GPA from a 1 point increase in the SAT score for an athlete would be what, that it doesn't predict as high of an increase, right? Because it's actually negative. So this is telling me that SAT scores, when I'm using them to predict GPAs, they don't predict as much of an increase for athletes as it does for these non-athletes, right? So what I'm doing there is, for whatever group belongs to the 1, I'm taking that coefficient on the interaction term and I'm adding it to the coefficient on whatever variable I'm trying to, understand the relationship between that and the Y variable. Right? So I could break this down to the two groups. Any questions on that? We did a couple examples like that. And like I said, if I'm just trying to interpret the coefficient on my interaction term, it's the additional kind of change in the predicted Y variable that's coming from a 1 unit change in the SAT score for the group that is coded as a 1, or for our student athletes here. However, at the 90% level, like I said, the 90% confidence level or the 10% significance level, can I actually say that a 1 unit change in the SAT score would predict any different change in the GPA for an athlete versus a non-athlete? Well, that's the interpretation of my interaction term. If I look at its p-value of 0.6, well, no, I can't actually say that there's any difference in the predictive power of SAT score for athlete versus non-athlete, right? Because that interaction term coefficient, the p-value is so high, I would fail to reject the null that it's equal to 0. Right? Any questions on that? Or if I change something or add else something in? So knowing how to interpret that coefficient on the interaction term, or think about coming up with the predicted change for the two different groups, whatever group is coded as 0, whatever group is coded as 1, excuse me, would also be a really good thing to know for the exam. Okay. I would also know how to use these interactions to make predictions, right? So if I'm going through here and it's okay, what would someone who's a student athlete, and so let's say they're a student athlete and they have an 1100 on the SAT score. What is their predicted GPA? You would actually have to go through, right? Take that athlete coefficient, multiply it by 1, add to that the SAT score. What did I say, 1,000? I don't know what I said. Okay, hopefully I said 1,000. But let's say they got 1,000 on the SAT score. But then I would also have to add in for that interaction term times 1. Well, I don't really have to times 1, but that's, to be complete. Multiply by 1 because they're a student athlete, and then 1,000 here as well, right, to make the prediction. So the predicted GPA for that athlete getting 1,000. Oh, what did I forget? Yeah, I forgot the intercept. I was gonna say that seems really low. So I have to add in that intercept as well, right? So when I'm making my predictions, I'm going through and plugging in an X value for this hypothetical person for every single variable, and then taking that hypothetical X value, multiplying it by that variable's associated coefficient, adding them all up, and then also adding in that intercept term, right? So 2.53, that sounds a little bit more reasonable there, okay? So know how to make predictions for your Y variable, but also how to use those interaction terms when you're making predictions as well. I probably wouldn't be as mean to throw a squared term in there and make you make predictions, but I would know how to deal with those interaction terms. And don't forget the intercept. Any questions on any of that? All right. How would I interpret the intercept here? Yeah. So yeah, so say it with some conviction. So if the SAT score is 0, right, and the person is not an athlete, right, if all the X variables are 0. So here we really only have 2 X variables, even though we have that interaction term. Well, once I say they have a 0 SAT and that they aren't a student athlete, that means all my X variables are 0, even the interaction term. So if those are variables equal to 0, the intercept is my predicted GPA. Yep. So here, if they're not an athlete and they had an SAT score of 0, their predicted GPA or the predicted value of that Y variable would be 0.67. And so it does often have a weird interpretation, but it's because, like, even though we have this line of best fit, even if we don't see data on the left side of that line, there still has to be some starting point. It doesn't just come from the ethos, right? Like, there is an actual starting point on like that X-axis. Now, once we start adding in more controls on that right-hand side, you can't really visualize it. It's not like starting on a Y-axis. It's starting in like this 8-9 dimensional thing, right? It's hard to visualize, but it still does have to have a starting point where everything's equal to 0. Okay. Questions there? I think between the day and the Friday, we've covered a large majority of what you can expect. So I would know a few things. Maybe I can try to kind of give you a synopsis here, a checklist, so to speak. So we didn't do it right today, but I would review kind of doing those matched pairs examples. This was where we had a little bit more of that kind of remnants of the hypothesis testing. So this is where we had that mean difference. We had a sample variance. You might have to do something like find a test statistic. Our degrees of freedom was n-1, so we could find critical values or p-values, make rejection decisions. Just as with our linear regression, our rejection decision is if that p-value is less than alpha. Right? So make sure you're okay kind of with those matched pairs examples, looking up critical values. What distribution will we use here? Yeah, we actually aren't using the standard normal for anything in this last section of the class. Right? That's because in the application, we always only have sample variances on different statistics. You would then want to kind of know how to do this, really focusing on this two-way factor ANOVA. So this is, actually, we didn't have a T distribution here, we had an F distribution, but I didn't make you like go and look up these values. Really here, all I want you to kind of know is if the p-value is less than alpha on either your rows and your columns, then you can reject. But what are we starting out assuming? We're starting out assuming that like the variation that exists in the columns, right, that these are all the same. So we're saying there's no difference across the columns. So if we can reject the null, what we're really saying is there is variation in whatever this variable is across this factor that we have in the columns, or if we can reject it for the rows, there is variation in this variable we're looking at across whatever this factor is for the rows. Okay, so kind of review those. When it comes to like regression, I would kind of focus on just like just kind of our general regression equations. Might be some of the easier stuff. We can calculate test statistics. We just take our coefficient and divide it by a standard error. That should be like the easiest problem probably on the exam. We can make, determine what has a significant relationship. So once again, this is if we can reject the null. So if we have a p-value less than our given alpha, we're saying there's a significant relationship, because we always start out assuming that the relationship is equal to 0. Okay. Just general, know how to interpret slope and intercept coefficients, and to be a little bit more precise. Also, if we have these dummy variables, which are 1, 0. Also, if we have these kind of categorical variables where we leave one out. Okay, know how to kind of make all those interpretations. Okay, don't just state the number. You have to say, like if this x variable goes up by 1 unit, this is the expected change, or belonging to this group relative to the other, the expected change. And also, once we include additional control variables, we also throw on the end there, holding all else constant. Excuse me. Okay, so that would be some general stuff. Let me make sure. Kind of just know what the R squared tells you. Right? It's the percent of the variation explaining. So models that have higher R squareds are really a better prediction for whatever that Y variable is. Also, know how to make predictions for Y. That was where we said we're just using those coefficients and these hypothetical values for X. And then it's just like a linear equation. Just, multiply the coefficient by the hypothetical value for the X variable, add them all up, include the intercept. And that's how we come up with our predictions. Okay. Questions on anything to this point? I'm going to add some more stuff, but I'm just pausing for a second. Okay. I think that gets everything, that kind of the general kind of stuff with these regressions. And then more specifically, probably for like some short answer questions, I maybe focus on the following. So, and they might not all be short answer. I'm just saying these are maybe some of the harder ones. So, understand kind of log level and level log relationships, right? So this one was 1% change in X, beta percent change in Y, or predicted Y. I'm kind of shorthanding this a little bit. When we went log level, remember the first word is always your Y variable, the second is your X. So because my X is in level, it's a 1 unit change in X. And then because I'm going from a unit to a percentage, I need to multiply by 100 to get it to be translatable as a percentage. Right? Oops, sorry about that. And then level log, well, now my X variable is taking the log, so it's a 1% change in X, is going to have a beta. Well, if I'm going from percent to units, I have to divide by 100 so that I can translate that as some type of unit change in Y. Any questions there? So review that. We had that one assignment. You kind of go back to that. Look at any comments I put on it for the work that you did. It was an individual assignment, so obviously like there's not like a universal answer key, but I at least told you why I took points off. So kind of review and make sure you kind of could come up with those. Go back to maybe the slides where we had some examples like height, weight, and then we did another. I showed you another one, and now I forget what it was. I don't know. We did one in class. I know we had two running exams. One was height, weight, and another one that we use a different data set on. Maybe going back and kind of reviewing those would be good. We already talked about it today, but know how to do those categorical variables and that you're going to leave one out. Go back and kind of review kind of these quadratic nonlinear relationship, kind of including that squared term. What else did we do today? Oh, review, kind of know how to deal with these interaction terms, right? And how what they're really telling you is the additional effect for a specific group of whatever that X variable is you made the interaction with. I feel like I'm leaving one thing out. So we got categorical and also make sure you can sign or put a sign to a bias that exists from some variable you've left out. And kind of here with this quadratic, I even mentioned today, make sure you know kind of how to find these marginal effects. Questions here? Yeah.
I know you've already, but I know I've asked this question before.
It's okay.
What was the quadratic thing again?
So this is where generally we just allow something to have a linear relationship, right? If it's quadratic, we're including this squared term, right? And we're allowing it to be nonlinear, right? It has some curve to it, right? So that was, yeah, that's kind of what this quadratic means. You're just square. You're including a squared term. If it's easier to think about, right? You're including a squared term. Why? Because you're allowing this relationship to not just be linear. Any questions here? It's probably all I got. So unless you guys have questions. Yeah.
So what's the regular time final Friday?
Friday at noon. We'll be here in here. Friday at noon is our kind of time slot. Do you guys know about the final exam schedule? Did I tell you guys about this at all? So
If there's something to know, I would err on the side.
so if you do yeah, so I found this out. I didn't realize that they hadn't told you some. So if you go here, this is always how it's going to be, right? Unless like the professor decides not to have a final, because I can't give you like if it's a 2-hour time slot, right? Then if you had a class right after this, so they give every single meeting time a specific time block and a specific day. So for us, we're what, a 3 credit hour course at where we start at 1 o'clock. We meet Monday, Wednesday, Friday. So Friday at noon is going to be our final exam. Right? So I don't make these times up like this. It's always going to be like, and they change it year to year sometimes, but I think this one has been the same for like the last, well, prior to COVID. So you could actually determine when your final exams are. I didn't know they didn't tell you guys that. I figured you guys knew this was a resource, but then I also failed to remember like you guys really weren't here prior to COVID stuff. So, so yeah. So you Google search Ball State final exam schedule. You can find this. Maybe next semester this will help you out a little bit more. I mean, I put it in the syllabus, but this is where it comes from. Okay. No more questions? All right. Well, thanks for a good semester. And I'll see all of you hopefully at least one more time this semester. But I appreciate the work you guys put in. I always enjoy this class. I love going through more of this linear regression stuff. You guys ever have any questions? If moving forward in other classes, I've had a lot of people kind of reach back out to me, especially when it comes to like data stuff. So always feel free to shoot me an email, stop by, knock on my office door if I'm there, or if it's open, pop in, say hi. And good luck with the rest of your study. All right.
No.